Buongiorno a tutti, grazie per avermi invitata a parlare. Avrei voluto fare tutto il discorso in italiano, ma lo sto ancora imparando. Per adesso posso parlare soltanto di gelato, o i colori, o cosa mi piace mangiare in Italia. Perché non so dire ancora, don't worry about LLMs. Il resto sarà in inglese. Okay, so a little bit about me. I'm Vicki Boykis. I work at Mozilla AI, which is a startup founded by Mozilla to do AI things. We're working on evaluating large language models. We're building platforms and tooling for that and open sourcing for that. By the way, all the notes for this talk will hopefully be available right after I finish it, and I can get Hugo to build correctly on my website. So while I've been building tooling for LLMs, what I've noticed is that a lot of the stuff is very similar to what I've been doing before. So prior to Mozilla AI, I've been working in machine learning for a number of years on recommender systems, on search systems, and on building ML platforms for security. And what I found is that both LLMs and these systems have a lot of things in common. So there's a lot of hype around them right now. But what it eventually boils down to is that these systems are just plain classical machine learning and classical engineering. So a lot of the time, around LLMs and AI, you might hear things like attention mechanism or LoRa. Really, a lot of what I'm doing is writing PyTest, building REST API endpoints, making sure unit tests pass, etc. Because the hardest part about AI apps is web development. So in that, how do we as practitioners cut through the hype and understand that you can link these two things together? And I don't know, but I heard a story here while I've been here in Florence that I'm hoping might shed some light on the situation. So I hear there's this really big company in Florence. It's called Medici Corp. They're very successful. They've been around for hundreds and hundreds of years. They specialize in banking, finance, art, and philanthropy. So they're very successful. They're international. But they have one problem, which is that they don't have any AI at all. Extremely profitable, absolutely no AI. So the CEO of Medici Corp has absolutely been worried about this. She's been reading a lot of stuff in the news about how you need to incorporate AI into all your applications. If you don't have AI, then it's bad. She thinks that this should be something strategic for her company. So she thinks that her customers should be able to chat with their data or do something similar. So what she did was she developed a task force, a small R&D team of developers that was built up, 10 or so. So there's SREs, machine learning engineers, there's a team lead, a PM, etc. And she said, go figure out something for us to do with AI, something valuable, and come back and report to me in a sprint. So these developers said, okay, I guess we have to demo something to the CEO. What are we going to do? So they decided to leave Florence because they wanted to really focus, grind, do JIRA tickets, get a sprint done, push this AI product out, and they needed to focus away from the city. So they went and they rented a house together. And they said, okay, now we're at the whiteboard. We're going to do AI. What are we going to build? They started doing some research, and what they saw was this. This is the current AI landscape. So there's a venture capitalist called Matt Turk that puts this together every year. And it started like sometime in 2012, and it just had Hadoop on there, basically. And since then, it's grown to this whole big thing. So there's open source infrastructure, there's tooling, there's libraries, there's cloud vendors, there's now LLM vendors on here, all of these different people. So the developers and the team looked at this, and they said, what? How do we build with this? What do we do? What do we even do here? Luckily, their team lead had some experience and said, in times like these, I turn to the wisdom of the elders. There's particularly one foundational thinker that I look at to guide me in times of great stress. And he said, in the times we live, a fundamental skill to survive is knowing what to ignore among the zillions of things presented to us every day, every minute, and in which things to focus our attention. Be picky as shit. Which is great. It's a great thing to think about, and it's a great idea. But then developers said, okay, well, how do we turn this into JIRA tickets? I have no idea. The question is, how do we actually deliver AI? So then the team lead was ready for this too. She's a really good team lead. She anticipated this. She said, well, let's look and see what other people have done already. There's plenty of engineering patterns that we can look at, plenty of blog posts. None of this is new. Let's look at what other people have done. Let's do some research. And what we're going to do is one person is going to tell a story per day on what they've researched. And then maybe we can make some decisions from there. And so developers groaned because not only did they hate doing research, but they also hated doing teamwork and presentations. But the team lead said, okay, just do it. Bear with me. We're going to get there. So then developers all went into their separate corners to do some reading, some research. And then they came together, and the first developer began to tell their story. And the first developer, the machine learning engineer, said, I've been reading about the bastaijos and what it has to do with a single task. She said, what I've been reading about is medieval churches. So there's this church in Barcelona called Santa Maria del Mar. And what's interesting about it is it's the only church built in the Catalan Gothic style that's still remaining. And it took much less time to build than all other medieval churches. So a lot of medieval churches took around 100, 150 years to build. This one took only 55. Why? Because it was built by the community. So it wasn't the king or the head of the church or nobles that decided to build it. The neighborhood where it was located decided to build it together. And so it was decided that the nobles would contribute their money, and people who didn't have money would contribute their labor. And in particular, there was one group that contributed their labor, and that was the bastaijos. So these were porters, basically, who carried freight from the port of Barcelona to the city of Barcelona, because the port was a little bit away, and they needed to get to the city. So they were very, very good at carrying really heavy loads. And all they had was basically this little turban on their back, on their head, called a capsana, that protected them from getting cut from the stones. And these weight was really, really heavy, but they were really good at this. And so their guild said, what we're going to do is we're going to carry stones to the church. We're going to contribute by carrying stones from the quarry to the church. So the quarry in Barcelona is located at Montjuic, on the top of a hill. You can see how high it is, because you can see the rest of the city of Barcelona from there. And from the quarry to the church, right now it's like about a 15-minute walk. I don't know. I didn't walk it because it's far and I'm lazy. But back in the old days, you would also have to walk around the port. So it was like an hour and a half that you would walk from the quarry carrying these stones. So basically, they had this stone that weighed 40 kilograms. They put it on their back, and then they carried it all the way down the hill to the church. They left it there, then they went back up and made another trip. And they would do this 5 to 6 times a day for many, many years. And then the architects would take the stone and then do whatever it is that people do to build really cool churches. Like they would chisel it, et cetera, et cetera. So while the machine learning engineer was telling the story, she paused and she said, wait. This reminds me of something. This is just gradient descent. And so gradient descent is a fundamental algorithm in machine learning which helps improve model predictive performance, aka how well the model does at predicting next items that it hasn't seen in its training data by making tiny adjustments based on how it did last time. So that's all it is. And it might help to illustrate this with a little bit more of a concrete example. Okay, so let's say we are a small artisanal producer of a hazelnut spread for statisticians, and this is called Nutella. Please don't sue me. So we produce Nutella when there's sunshine. We're motivated to produce Nutella when there's a certain number of hours of sunshine in the day. So we keep track of the day that we produced these jars and how many hours of sunshine there were. So you can see on Monday there was 1 hour sunshine and we were motivated to produce 2 jars. At this level you can see there's a pretty small relationship, but what we want to do is actually quantify that relationship. Let's say we want to know how many jars of Nutella we're going to produce next Monday when there's 5 hours of sunshine or 0.5 hours of sunshine or whatever. We want to quantify the relationship between the jars and the sunshine. So what we have is we have to create a formula for how we can predict the output. So the output is on the very left. We'll start from the left. We have the jars of Nutella that we produce. And then we have beta 0, which is just the predicted value, which is how many jars of Nutella we produce when all else is 0. We don't really care about this as much because we care when there's more hours of sunshine, but in general, yes. And then we have our actual hours of sunshine, which is x1, and then how important that feature is, so how important the weight is. For us, it's pretty important because it's our only feature, but in larger equations where you have more features, you'll have different weights. And then we have an error term, which is a residual, or the difference between the predicted and observed values. So really what we're trying to do is we're always trying to predict y based on all these other inputs, particularly the weights and beta 0, which is the bias. And we're always trying to make epsilon, the error term, smaller. That's all we're trying to do in this equation. How do we make it smaller? We want to minimize RMSE, which is mean squared error. So the way we do that is we have the actual hours of sunshine and the predicted hours of sunshine. We do some math to it, we square it, square root it, and we have the actual formula on the left-hand side, and we're always trying to make that smaller. We're checking the difference between what we predicted and the actual values, because we have actual values before, and always trying to make that smaller. What do I mean by always? We're descending the gradient in a loop. So this is kind of Python code, it's kind of pseudocode. It's like somewhere a mix between the two. So we start by initializing our weights, which remember we had 1 hour of sunshine, our bias, which is 0. And then we have this thing, costs, which is all the iterations after we calculate mean squared error. So we start with our equation on the first line in the for loop, and we say we have this number of iterations. For our purposes, we can pick 10 or 100 or 1,000, however many we would like to get our cost to converge, aka get to a value that we're comfortable with. So then we do the prediction of the predicted y, and then that's our cost. And then we add that to the costs, and then we go through the loop again. If it's at or below the threshold that we'd like it to be, we stop. Otherwise, we keep going. We calculate the current weight. We calculate the derivatives, weights, and biases, and then we append those to the equation. And we keep going over that again. And so at the end, what we have is this list of costs. And if you look at the list of costs over the number of iterations, what you can see is we have a slope of a curve, which looks a lot like the elevation descent that the Bastaijos made when they descended from Montjuic to Santa Maria del Mar over and over again. Because gradient descent, as Sebastian Reuter says in this really great paper, is basically the art of going downhill until you get to a point that you're satisfied with. That's it. We follow the direction of the slope of the function until we reach a value. So the developers all paused, looked at this, and said, we need to be Bastaijos. We need to focus on one thing when we want to create the software that builds AI, which is really hard because large language models can do millions of things. They can do translation. They can do QA. They can write you poems. They can write you a talk in the style of someone else. They can do all these things that are on this and a lot more. How do you pick, when you select a large language model as your tool, how do you pick it to do one thing? Because it's meant to be general purpose. And the answer to that the developers said, is to look at your actual business problems. What business problems do you have? Do you have a question answering problem? Do you want to do translation? Do you want to do word completion, etc.? And a good heuristic for that is the 1,000 interns heuristic, which I've heard of, and I link to the source once I have the notes up. But basically the idea is if you have 1,000 interns who are reasonably smart people but have no context about your business or your problems, and you sit them in front of a problem and you give them a small set of instructions, would they be able to do it? If the answer is yes, then you can make an LLM do that. It's a perfect use case for that. So some specific use cases are translation, topic detection, summarization of documents, classification, and named entity recognition, so recognizing the words that you care about in any given text. So the developers and the team all got together. They thought about this. What use cases do we have that actually might require machine learning and LLM specifically? And they thought that they have a lot of documents relating to sponsorship. As you know, they are very much patrons of the arts. They have a lot of artists, the Medici Corporation, that they sponsor. There's a lot of documents floating around. And what they want to be able to do is pick out topics from those documents that they care about to get a better sense of the landscape of the artist that they're sponsoring. So for example, if they have a bunch of topics related to Michelangelo, a bunch related to Botticelli, and a bunch to Da Vinci, they want to be able to say that Michelangelo is related to statues. Or they want to say that Botticelli is really into myths, and they want to pull that and do analysis on it. So they thought about this, they came to a conclusion, and they presented it to the CEO, and the CEO was very happy. She said, topic detection, great. When can I see this model? Can it be yesterday? So they had their first solution, but now they were ready to move on to the next step, and they were still doing research. So then the second person got up to tell a story. And the second person said, I've been reading about medieval monks. I don't know why, but that's where my research took me in that direction. She said, I was reading this book called The Wandering Mind. It's by a historian called Jamie Kreiner at the University of Georgia, who does a lot of research on medieval type stuff. And she was really interested in how monks find focus, because that's all medieval monks wanted to do. They wanted to get to a point where they're concentrating really on praying and on their spirituality and kind of shooing away anything that has to do with daily stuff. The problem is, even in the Middle Ages, apparently there's a lot of daily stuff going on. Like, I don't know, I'm just speculating here, like livestock trades, gossiping, I don't know, creating weird manuscripts, etc. So even in the Middle Ages, people had the same problem of they could never concentrate on the one thing they could concentrate on, even though there were no phones or anything like that. And so there was one medieval monk who wanted to concentrate so much that he went from Europe to what is now Egypt and Israel, in that area, and he lived there for 25 years because there were a bunch of monasteries in that area. And he went around to each monastery and asked, how do you concentrate, guys? How do you concentrate? And then he wrote all of that down. And even he said the mind keeps getting pushed around by distractions. Now, back in the day, they thought this was basically demons that did this, not the iPhone. But you know, it's like kind of the same thing. And what these monks found was that they needed to create the right environment because they knew that these distractions would always be constant. There was no one solution for how they could show away these distractions. So they did a bunch of stuff. Like some of it was weird, some of it was cool. Like some of them went to live alone for years and years and try to meditate and get to a higher level that way. Some of them didn't bathe for a number of weeks. I don't know how all that went for them and the people living in the monastery. Some of them ate only certain things. Some of them meditated in nature. But the point was they knew that this required kind of a system of things because the human brain can only concentrate on one thing at a time. And so there was another monk called Hilmar Sivatai that said, it is impossible to focus on two things at once. And later, science actually proved this with a study by George Miller, which Feline Hermans wrote about in The Programmer's Brain, which is a wonderful book. I strongly recommend it to everybody. And said that humans can only fit 7 + 2 things in memory. and really less than 7. So if you get to the point where you have, if you think about like a grocery list, if you get to 7, like you have a push and it clears the cache, because you cannot think about any more than that. And really the best way to do this is to concentrate on one thing. And so when the developers looked at the LLM system that they were building, they saw that it started to get complicated immediately, because first they had to pick an LLM to use. So that would involve either an LLM API or their own model. If they had their own model, then they would need to create storage for the model. They might also need a vector store if they were doing embeddings or RAG-based search. If they were serving it, they also would need a model engine and a model server to stand all of that up. They would also need a UI, and regardless of whether it was on-prem or they picked a vendor, they would need prompt optimization. And as you see, like this starts to get complicated very quickly, because then you start having a number of different questions that are concurrent in your mind, like which API do you pick if you're using an LLM vendor? If you do this, do you build or buy? Do you build the vector store? Do you buy the vector store? Which cloud storage do you use for any of this? What kind of latency do you care about? If you're hosting a model, are you now using Kubernetes? What's the throughput of, etc. So there's a lot going on, and they thought about how do we break this down to one thing? And then the developer telling the story said, this is really just about Unix. And what they meant by that is the philosophy of Unix, which says that each program, regardless of what we build, should do one thing well. To do a new job, build afresh rather than complicating old programs by adding new features. That's the philosophy of Unix. How does this square with the fact that machine learning requires quick feedback loops? As you saw in the gradient descent example, we're always looking at our data, we're looping over it, and then we're comparing. We're comparing the old value and the new value, we're seeing if it's better, we're doing another iteration. Then we're comparing the old and new again. That's very different from the way we traditionally develop software, which is just we build one thing that makes a button green, or we build one thing that writes data to the database. It's very, very non-deterministic, and it's very, I don't know, like hand-wavy and vibey and etc. Which is why if you're a project manager and sometimes you go to your machine learning engineers and they're like, when is this going to be done? Well, we don't know. What does it mean to be done in machine learning? It's very much an iteration-based cycle. So the difference is that in machine learning, we start with data and learn the rules. When we create a traditional application, like a CRUD app, we start with data, or we start with our rules, and then we build to the answers. So the way machine learning works, as I said, it's very circular, and it's also more like alchemy, which is actually the title and the content of a talk that two famous researchers gave in 2017 at NeurIPS, which is a machine learning conference. They basically said it's like alchemy, because we're constantly looking at what we have, seeing if it makes sense, and then throwing more numbers against the wall, seeing if it makes sense again, tweaking this, tweaking a hyperparameter, and seeing if it makes sense again. So how do we focus on this one thing? How do we get to a system that does this one thing well? And the way to do that is to get to a state where you're constantly evaluating your LLM use case and focus on that as the endpoint. So how do you do that? You can evaluate large language models or any machine learning model, but particularly large language models in two ways. You can do a vibe check. I stole this from Zach Mueller, who I thought had a really good one. It's basically like, oh, you look at it, oh, it looks good to me. Okay, great. Or you can look at offline metrics, which is basically an aggregated vibe check based on statistical reasoning and properties that academics have looked at for benchmarking. So there's a bunch of offline metrics as well. The ones on the right are particularly for trending topic analysis. So there's purity, there's cosine similarity, and there's dot product, which I'll get to in a minute. So let's think about the vibe check first. How do we as humans decide what trending topics are? So here's Michelangelo's Wikipedia page. I just copy and pasted a lot of it. There's a lot of words in here, blah, 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 sculptor, blah, 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 classical antiquity, blah, blah, sketches. So your mind kind of pulls out like what you think the top topics are based on your domain expertise. And your domain expertise is you work at the Medici Corporation as an art philanthropist. So you already know this word, you know which words are the most important to you. And so you pull them out kind of like in your mind. And you say, okay, here's my text, here's my original text, And here are the topics that I think are most important for this piece of text. Now what you do is you feed it to an LLM. And in this case, I'm using a local LLM, using LlamaFile, which is a wonderful project. And basically, it lets you run an LLM in a single file on your local machine. You can also run on GPUs, but I just run it on CPUs in my Mac. And so for this case, I'm running Mistral 7B Instruct v0. I know we're at v3 right now, but etc. So what you do is you create a prompt, and you feed it to the LLM, and you let it answer it. And so for this case, he says you will receive a document, top-level set of topics from a hierarchy. The goal is to identify the missing topics, and like you have to yell at the LLM a little bit, like don't stray, don't do weird stuff, please just pick from these sample topics, etc. And then you have your instructions, and you can just run this locally. That's another part of Focus, is you can run a local iteration loop very quickly. And then the LLM will come up with some topics for you. So then what we do is we compare the human vibe to the LLM vibe. Do these look kind of like they make sense? Yeah, kind of, I guess. As an art expert, I probably would think that Renaissance art, sculpture, painting is general. Like, I mean, everybody's doing a Renaissance now. That's old news. So we don't want that as a topic. Art, okay, yes. All of these are artists. We don't want that. Sculpture and painting, maybe. Music, we don't want as a topic. So we can already see that the first pass at what this LLM gave us is not really good for what we want. It's not really a solution for our problem. So then we get into levels of modifying this. The first level we can do is prompt engineering, right? So for example, we might yell at the LLM a little and say this topic should only be related to art and more low level than Renaissance. Do not give me Renaissance. Then we might cross out Renaissance because it picked it, because it saw it in our entry text, and pick sculpture instead. So there's tons of tweaks that we might do like that. Remember, again, we're iterating. So we might have to iterate through the prompts. We might have to change our model depending on what we have. We might have to fine-tune our model. We might have to do a lot of different experimentation. But what we always have to be doing is evaluating the results of these things, and doing that will get us closer to what we actually want, because most likely, if we're doing something specialized, we will not get to it the first time. And then there's formalized metrics that we can do, the offline metrics that I talked about. So there's cosine similarity, which looks at the topic similarity between trending topics in clusters. So we can cluster it and then evaluate it that way. And that'll give us something more automatic than just a vibe check. And there's a lot of these different types of metrics. So they evaluated it. They got to a model that they liked. And then they showed it to the CEO, who said, I love these generated topics. Great. When can we see this in production? So now they had step 2, but they still had one more place that they needed to focus on. Now they picked this model. They picked an open source model. They wanted to host it locally because they had compute, because the Medici Corporation has a lot of compute and its own cloud, etc. Great. So they have this model. They have a production. They have a UI for it. But as soon as you have a model, now you have an LLM application, and you have this horrible thing known as LLM ops, which is just like ML ops, but more. So you have 5 million different things that you now need to be monitoring. You need to be monitoring the performance of the model, of what text it outputs, because remember that LLMs are not deterministic. They're also going to give you, depending on how you set your hyperparameters, different answers every time for this stuff. They might give you weird stuff. They might give you bad stuff. They might give you stuff you don't want. So you have to monitor that. Then you have to do classical engineering monitoring, right? So if you're running this on K8s in a distributed system, you have to monitor all of that, all of the storage for it, etc. So you start from something very, very focused, which is we picked one model for one task. We evaluated that model. We know it performs well, but now it's exploded into an engineering system that we now have to handle and control. And so they did their reading again, and the third developer spoke out and said, I've been reading about Ellen Ullman, and a reproducible example. Ellen Ullman is an author who was working in tech in the 70s, 80s, and 90s. She's a wonderful essayist. I find a lot of the stuff that she writes is very relatable to tech today, even though she was writing for what is now back in the day. And she has a lot of essays. And one of the essays she turned into a book. There's a book and an essay. There's an essay called Closer to the Metal and a book Closer to the Machine. And her whole point in that is that as developers, we need to be working closer and closer and closer to the part that's more important. And the way she said this was low-level code or anything low-level in real life is bad. Anything that is in programming that's low-level is better because it means it's closer to the essence of what we actually want to develop. I don't know about the part about money and prestige, but in general, it's good to write code that machines and other programmers can understand and to be able to make it testable. Because when you do that, you really get to the heart of the problem. You're working on things that matter. And she was talking about this in a very general sense. I find that it applies today a lot to cloud programming, where you're copying together different components and trying to glue them together, etc. A lot of the times it's untestable, especially if you have distributed systems that you're working with. You often end up needing to rerun things a million times just to replicate the condition, and you can't clone S3 onto your local machine, so then you don't know the behavior of S3. There's actually just like a recent story about how they were charging for basically 404s to URLs. So you can't test that. You don't know the behavior. What do? So the answer is kind of to like write code in the old days, where you basically just had you and the machine and a million bugs, obviously. And then you had books and guides to read. So kind of like a similar thing would be working locally today and only using python.org, which is not a very good user experience, but it does make some things a lot clearer for you. So let's say that you can't do that. Let's say that you're working, as most of us, in cloud environments where you can't reproduce things, you can't test some services. What do? The goal is to get as close to a reprex as you possibly can in order to get to good, clean code. And a reprex is a concept from the R community, so from the R software community. And the idea is that a reprex is a reproducible example. And they created this term because a lot of the time they work in R or R Studio, which is a single piece of software, so it's a little bit easier to do reprex in that environment. But the idea is that you want to have a small snippet of code that can run on somebody's computer, that can be extremely easily tested, and that you can just pass off and say, okay, it doesn't work on my machine. Well, it doesn't work on my machine either, so what are we going to do? Now we can fix this bug. What's an example of a reprex that I talked about a little bit earlier? It's root mean squared error, right? So you have one method call, you pass in floats, you get out floats. It's going to work the same in any Python, maybe, I don't know. I'm getting into a hotly debated gray area here about Python environments, but this should work the same in any Python environment that you work in. And you can give it to someone else and say, why is this working or not working? So in that way, it's basically spiritually similar to a unit test. And so they said, okay, well, what is one way that we can test this? So the developers decided at the time to use Ray, which is a Python library for distributed computing. It's a spiritual successor to Spark in a lot of ways. It's used for a lot of large language model training, sometimes serving at this point. So it's also a lot like Dask, except particularly in the large language model space. And they decided to use this to serve the model that they had chosen and selected. Now, Ray is really, really complicated, like a lot of really distributed systems. So there's a number of orthogonal, sorry, I said orthogonal, but there's a number of orthogonal points happening in Ray. So first is the design of itself, where you have a task and an actor. So it follows the actor pattern of where you have stateless tasks that are sent to a given Ray cluster, and then actors, which are stateful applications. So first you need to understand tasks and actors as the first starting point for a Ray cluster. Then you also need to understand that these tasks and actors run on a driver, and you have worker processes happening. Then you also need to understand all the potential parts of an array cluster. So not only is there a head node, a worker node, however many worker nodes you have, once you add more, you add an infinite number of complications. Then you also have the global control store, which is kind of confusing the first time I saw it because it's GCS, and I thought it was sending all my data to Google Cloud Services. And I'm like, what is happening here? But it's the global control store, which controls all the state. Then you have a scheduler. Then you have an object store. There's a number of different paradigms happening in each stage of Ray. So when you pick it, it's really powerful. But remember that humans can only do one thing at a time. They can keep one thing at a time while in memory. And when you're working with Ray, you have this whole messed up little cake of things that you have to have going on in your mind as a developer, right? So first you have the Python fundamentals, because you have functions, you have classes. Then you have the actor pattern on top of that. Then you have your deep learning model architecture, which you have to understand how that works in order to be able to load it in Ray. Then you have, like I said, the Ray actor model. Then you have how all of this acts on GPUs, because that's very different from how CPUs work. And moving data from GPU to CPU is also very, very different. Then on top of that, you have, oh Lord, Kubernetes. So then you have Ray, which is a distributed system, running on Kubernetes, which is another distributed system, possibly running on a cloud, which is a third distributed system. And now you're in hell. And then on top of all of that, you have your Python environments, which you also have to keep track of. Okay, so now that we know that we have to keep all of that stuff in mind, let's serve a trending topic model. So this is using RayServe. And essentially what RayServe does is it uses this actor pattern to set up what is essentially a web service, a long-running web service. It has a REST API server. It has ingress. And then you can replicate it, because the whole thing with Ray is that it can work on multiple nodes. How do you set one of these up in production? So there's a number of ways you can work with Ray, and one of the really cool things about Ray is you can run it locally. So that already makes your feedback loop faster, because you can run it on a single machine. And I believe you can also now run it in multi-cluster mode if you tell your Mac to do bad things. So then we have this RayServe config file. Now we have YAML, yay. So the way you serve it is you specify your application name, where you import the path from, the deployments, and then all the regular Kubernetes type stuff, so the number of replicas, health checks, CPUs, GPUs, et cetera, et cetera. So this is good on the one hand, because what it does is it ships your working directory, whatever you specify and whatever you bundle in there, to the cluster. So what it does is it takes that, it takes it as a zip file, and then it ships it to the Ray cluster as a working directory. However, because ironically YAML tries to simplify things for you, it actually creates more complications, because if there's a failure point in serving the trending topic model, as the developer saw, it can fail in any number of different ways. It can fail in the import path. It can fail in the working directory if you specify it from a pin git hash. It can fail in the pip import if you specify the wrong version of machine learning library, because they're often quick moving and sometimes in conflict with each other. And then it can also fail in Kubernetes, et cetera. And that's exactly what happened when our developers tried to serve this model, and it didn't work. And there was a failure in the package imports, and they were like, okay, what do we do? Like, which part of the cake is this a failure in, even though it's giving us an error message? And so what they saw was that the package is trying to do a relative import. It seems like an easy Python error, and maybe it is, but now we have to look through basically all of Ray to see what's going on here. So we have to go through all of the levels of Ray internals. So we have to look at the dashboard, which interestingly enough is where a lot of the key Ray code is stored. Then we have to look at if it's an error in RayServe. Then we have to look at Ray core. Then there's multiple languages that make up Ray core, so then we have to look in Ray Python. And finally, when we dig through all of that, what we see is it's in this file called _private/utils.py. And what we have there is the code that now we can finally reprex. So this is actually from that utils.py module. This is the code that does the import of the directory. And so what they did was they isolated just this method. And what they did was they started to call it. So first they called it with this path. And that didn't really work for them. And then what they saw was if they didn't have a relative import, if they just had the exact import as is, this actually worked to serve it. So what happened here was they were able to isolate the problem, go through all of the layers of Ray, and get to a point where they were able to offer a solution. So now, what happened is that they had a trending topic app, and now they were serving it in production. So now they were happy, they could go home. They did this all in 2 weeks, by the way, but they were celebrating. They said, okay. Of course, their celebrations didn't last long because the CEO came around and said, I love that this is in production. When can we do more? Because success means that they can now do other things with LLMs. They understand all the basic patterns that this gives them. They understand where their errors are. And they understand where to go from here. So they got together in a retro and said, okay, now we have to build another LLM-based application. What are we going to do? Where are we going to go from here? And they realized after reflection that they have to take these 3 things into account. So how do you actually stay closer to the metal? How do you get to the point of what matters in building, particularly in a time when we're working with large language models? There's a lot of AI flying around, a lot of hype, a lot of different terminology, a lot of people trying to sell things. How do you get to the point that actually matters? And it turns out that the answer is that it's still the same as general machine learning and as general engineering. The goal is to pick a single task. In machine learning in particular, this means for LLMs, picking a single task that you want your LLM to do. So if you are, for example, MetaCheat Core and you're trying to get it to identify trending topics, you don't care about it writing poems. You don't care about solving reasoning problems. You care about this very, very specific use case. And that's why a lot of people are now actually going into smaller large language models that are more trained or fine-tuning their data sources for this task. The second thing is to pick a measurable goal. And you can do that in one of 2 ways. One is to do the vibe check with what actually resonates with you and your business. And again, sorry about this, but stakeholders. And also do this in a reasonable way. So if you're a company that is serving a SaaS product, do A/B testing. See how this performs in testing. Do internal testing. For example, Databricks had people in Databricks actually label the data for the model, for domain expertise. So do that as well. So pick the smallest measurable goal and do both offline and online metric testing. And finally, from an engineering perspective, you're going to be working with a lot of different pieces, as we already all are. We have a lot of different libraries working together. We have cloud, non-cloud, on-prem. We have different services. For testing, pick the smallest piece of code you can possibly get to and try to reproduce it locally, because that's going to save your sanity. And once you do all of these things, that means you will have moved closer to the metal. Thanks, everybody. Thank you.
Thank you, Vicki. Sorry. Okay, so we'll now take questions. As usual, you can put them through Slido with the lasagna room. There are no questions at the moment in Slido, so we can do them live. In the keynote, sorry. It's the first time I do that. Of course, it's not working for me at the moment. Okay. Okay, so we'll do it the old way. Who has a question for the moment? While you think a little bit for the moment, so we have this, I can start to break the ice. We have this situation in which now many Medici corporations are asking everybody to do AI. From your point of view, do you see that there is an escape to this, or is this something that is going for quite some time?
I think there's going to be, it seems like now there's an inflection point where, is my mic on? It is, right? Yeah? Is it on?
Yeah.
Hello? Test.
Okay. How are we doing with her microphone? Mine seems
Test.
working fine. Otherwise, I will
good?
give you mine.
Oh, good. Okay. Yeah, so I think we're at a point right now where, like, the last year was everybody trying to do everything with AI, but now we're narrowing and coming across actual use cases, which is actually why I came up with this idea for my talk, because there's a lot of stuff that really does deserve or need these types of models, like summarization, for example, as I said, topic detection, etc. There's a ton of good places where you can actually, and it might make sense to use these models. So I don't think it'll go away, but I definitely think it'll be much more focused going forward.
Okay, so we start getting question. The first question I have here are, what are the most important projects by Mozilla AI?
Yeah, so the first one that we have open source and shipped right now is LM Buddy. It's a platform and library and framework that allows you to evaluate and fine-tune large language models. So you can look it up on GitHub. And we're also working on developing a platform to do similar things. Stay tuned for more on that.
Okay. Thanks. The next one will be, will it ever get simpler?
No, I don't think so. I don't know. People who have been in this career longer than me can tell you that whether it will or not, I think we will get to a point where we're at like higher levels of abstraction, so you don't need to know the levels below it as much. I don't think, I think once cloud started, it really couldn't get simpler, because almost nobody, there's like 5 or 6 companies that are moving off cloud, but nobody's really moving off of it. But the thing is that you have the power as developers in your organization to push for things to be simpler. As technical people, we have the power, and I say responsibility, great power, great responsibility, etc., to push for solutions that are simpler and say, hold up, wait, let's try something else.
Okay. There's a very specific question about Llama-File. Yes. Is Llama-File a project by Mozilla AI? What is its main purpose?
It's a project by Mozilla, so parent company, Mozilla. And the main purpose is to allow hobby developers or anybody who doesn't have access to GPU cores, just really anybody who doesn't want to use or can use GPUs, to do things locally. And more than that, it's a project to allow you to do everything in one file. So it's literally one executable that you download, and then you download the models that you want, and you use it with that. And it also has a web server. It's great. I use it a ton for prototyping different stuff with LLMs, because you don't need to pass an API key. You can do everything locally. I could give like the whole talk about Llama-File and Justine Tooney's awesome work on it. But yes, if you want to play around with it, it's a great, great way to do that.
Okay. The next one is by Nicolas. If someone wants to get up and say their question, I can go and get you, but if not, in the meantime, if you can turn it on again. Nicolas is asking, what about the next non-conf?
No, next question. No, I don't think it's going to happen anytime soon.
So for those who don't know, NormConf was a great conference that was organized by Vicki. And okay, and other questions? I don't have them at the moment in this app, if I'm able to operate correctly, but I think I am at the moment.
There's a question.
Yep. Okay, thanks.
So what do you see as the utmost big problem in AI? Like what is the biggest challenge you see ahead?
I think, honestly, finding the right use case that makes sense for your company, for whatever you're doing locally. And which I think is why I gave this talk, like basically you need to find the thing, because it's so broad and there's so many choices. And it's like, do I use local models? Do I use OpenAI? Do I use Anthropic? Do I use this? Do I use that? So it's finding your use case and really narrowing in on it, because there's a lot of noise, and it's really hard to understand like who's talking about something genuine or who's talking about noise. So all of that.
Okay. Yep. Another question over there.
Thank you for the keynote. I had a question. We've been working with LLMs for a client of ours, but since from Italy, we're always struggling with the fact that basically all of these models just excel at English, but then there's the rest of us, right? How do you think we could mitigate and lower the barriers for those models and this application to be useful and produce like reasonable results in other languages, such as Italian?
In other languages? I think possibly the best way is fine-tuning. Like I know there's at least 3 or 4 different Italian fine-tunes going on right now, like Lamini. There's a couple other ones. But I really think like for language-specific things, because the current wave of models is supposed to be general, English language internet, etc. So really like the best way to do anything with machine learning is to get better data. So, and that involves like data specific to that language for including sites that like maybe, I don't know, the original model builders didn't consider, like specific subreddits or newspaper sites, etc. So the best way is to just get better data in that target language.
Okay. Another question.
Thank you very much for the keynote.
Sure.
In the last month, I've seen the knowledge of how to design a software system around large language model more and more valuable. Do you have any good research to suggest in order to learn generative AI system design, so to call it? Thank you.
Like I said, a lot of what I do is build REST APIs. So if you know how to build REST APIs, that's like 80% of it. Less blasé, I don't know offhand, because it's such a new topic that there's not really anything concrete to that. I know a lot of different posts, but there's no canonical resource for it yet that I know of.
Okay.
Okay, you mentioned Rust. So I have a question. Do you think that more and more Python libraries will have Rust in its backend?
I don't know. That I have no opinion or expertise on.
Okay. Let's see if someone else has other questions. Yes.
Thank you, Vicki.
Sure.
In your story, do you think the CEO got a bit lucky with the results?
No. In what way?
Well, of a number of CEOs, how many of them would be likely to have come up with something that did seem to be producing value from them going down these paths? And how many of them do you think would have barked up the wrong tree completely?
I mean, I think it's common in machine learning in general, right? Because it's very iterative. We don't know how it's going to work. At the beginning, it's very murky and very research-based. So in some senses, yes, but a lot of it was the team, the team's work, right? And finding out really what mattered and focusing on that part. So I don't know the answer, but yes, machine learning is very non-deterministic, and a lot of it involves a lot of very, very focused research. Yep.
So a follow-up question to this. So when you take an original, like a classical engineering team that can have a known velocity, how do you build safety and predictability in new AI ML teams?
How to build safety, and so how to maintain velocity, I guess, is the question?
Team safety.
Team safety. Okay, so are you talking about like the fast pace of iteration with this? Well, I think it's up to like the team lead here, to kind of push in both directions, right? I don't know. I'm not an expert on team leads, but I think like what I've seen in places where this worked really well is that the team lead pushes up and sets expectations, saying, look, this is a new area, we're entering an R&D phase. We're going to be a little slower for a while until we figure out. We're going to give you regular feedback on our cadence. But you have to understand that for us, this is completely new and greenfield. And if you want like regular updates, yes on those. And then to push down and say, okay, here are the expectations on here. So maybe it's not up and down. It's just like you have to communicate in both ways. And like really the only answer is open communication. That's the only way to make sure that the developers are not working in the dark and leadership understands what they're working on.
Okay, other questions? Yes. Thanks. Okay, so how can LLMs balance effectiveness with ethical considerations?
Yeah, so this is part of the research cycle. So I guess I'm not entirely sure what the question is, but if I had to interpret it, I would say maybe an LLM is good, but it's not fair for whatever definition of fair we decide is important to us. So how do we balance that? And the answer depends a lot on like the culture of your company, the culture of your team. From a personal perspective, I think it's important to, like I said in the previous answer, communicate and share and do a lot of testing. Because there's a lot of different edge cases with this. There's a lot of times when LLMs have said weird or bad things. So before you launch a product like this, really consider that and then set the expectations that, again, this is non-deterministic and it might produce wrong output.
Okay, we have another question from remote. The pyramid of what one needs to know keeps growing, it seems to me at least. How do you stay on top of all the technology? Any tips?
Yeah, so I wrote a blog post about this, so you can check on my blog. It's like how I learn machine learning, vickyboykis.com. That's one way. So what I wrote in that blog post is first, you need to develop a broad base of general good engineering skills, because that's going to take you really far no matter what area you work on regarding this, engineering fundamentals. Once you learn those, like the space keeps growing, but it's really not, because in some senses, like, oh, okay, we built a cache. Well, a cache is just a Python dictionary. It's just X, it's just Y. So these concepts all start to relate to each other as you gain mastery over all of them. So it's really not like or for example, like LoRa is a new fine-tuning technique for large language models. Oh, okay, LoRa is just a type of fine-tuning, which works on all machine learning. So you start to kind of like, it's big, but it's not as big because you understand the fundamentals. So yeah, but the long answer is that blog post.
Okay. If no one else from the audience has any questions, let's thank Vicki again.
Thank you, everybody. Thank you for coming. Thank you.